Hello my dear student, hope you are fine and taking care of yourself at your home. Today we will do the topic of electromagnetic induction but in a different way. So before starting the topic, please do like and subscribe my channel and press the bell icon button for further notification. In the previous class or video, we have done electromagnetic induction using a moving bar magnet and a moving coil. And we have seen that the current is induced due to the relative motion between the coil and the magnet. Today we will do, but today we will not use the bar magnet, we will use the two different coils. So let us do that. First of all, we will take a coil of large number of two coils we will take, having the large number of turns, say 50 turns and 100 turns. So the coil which is having more number of turns, and both the coils are wrapped on a non-conducting material like a cardboard paper or like that. So it is wrapped on a non-conducting material. So the coil which is having large number of turns is connected to the battery or the key in series. Before, don't plug it. So in series we have connected this primary coil. What is the name of this coil 1? The name of the coil 1 is primary coil. Now the another coil is connected which is having less number of turns. So that is connected to galvanometer. Galvanometer detect the presence of the current in the circuit. So this is at the center and it is connected on a non-conducting wrapped on a non-conducting material. This is a cardboard for wrapping we are using it. So this coil 2 is known as, two coils we are having. One is having large number of turns, say 100 turns, and one coil is having like 50 turns. So coil 1 is known as primary coil and coil 2 is known as secondary coil. So what we will do, first we will make a setup like this. Now what we will do, we will plug the key. Suddenly when the key is plugged inside, here, then what would happen? Current start flowing in this coil. Because of that, suddenly we will observe the needle get deflected one side. The galvanometer, say towards the right side, it get deflected and it again come back to 0. Again it come back to 0. Momentary it will go to right and still key is plugged, but it comes to 0. Now in the second case, we will remove the key. What we will observe, just when we will remove the key, the galvanometer needle will go towards the opposite direction, say towards the left. But again it will come back to 0. The needle deflects on right and left and within a second it comes to 0. So this what you have observed here, कि when the current reaches to the steady value, from minimum to maximum value, still the current is flowing, then the needle comes back to 0, or when it is 0, then also the needle is not deflected. It gets deflected only when there is change in the current. Like from this coil, let us assume that 2 ampere current is flowing. So there is a change of the current from 0 ampere to 2 ampere. Till then, means 0 to like 0.1, 0.2, 1 ampere, or like 1.5 ampere or 2 ampere. So till the current is going from these steps, or then this process is very fast beyond our imagination. So till then the needle goes fast towards one side, or once it reaches to 2 ampere, its maximum value, then it comes back to 0. Same process happen when will you take out the key. Whenever you are inserting the key, this process is going from 0 ampere to maximum value. So till the change is there in the magnitude of the current, the magnetic field line associated with the coil 1 get changed, and due to the change in magnetic field lines, strength in the magnetic field lines in the coil 1, in the coil 2 also magnetic field lines get changed, and because of that strength of magnetic field lines get changed, so current is induced in the coil 2. And the same opposite is also there. When you will plug out the key, then what would happen? The reading 2 ampere to 0. Whenever you will plug out the key, the current reading decreases from 2 ampere to 0. So what happened? So there is a decreasing order. So when it is decreasing, it deflects on opposite side, and when it becomes 0, then again it comes back to, needle comes back to 0. So this shows that whenever either the value is 0 or steady or constant, then there is no change in magnetic field line strength. So no current is induced. But current is induced whenever there is a change in the magnetic field line strength. Now the question arises how to find out the direction of this induced current. For that, the rule is given, and that rule is Fleming's right hand rule. Here, what is this rule which is used to find out the direction of induced current? It tells us direction of induced current. It tells us the direction of induced current. How to find out? Stretch the thumb, forefinger and middle finger or central finger of your right hand. Thumb, give the direction of motion this time, motion of the coil. Forefinger, give the direction of the magnetic field. Then the central finger would give the direction of induced current. So in this way, we can induce the current by changing the magnetic field strength, and this more conveniently we use this property by moving the coil in a stationary magnetic field. The example where we induces the current are electric generator. For today, this is our topic. Revise it and have a nice day.